of California, San Diego in the US. And I'd like to thank the organizers for giving us an opportunity to talk about educational robotics, because we don't really have that many opportunities, especially to the audience who are really in the field, robotics scientists. So I want to thank for the organizer for the opportunity. That's the reason I'm here all the way from San Diego, 20 hours trip to be here for 15 minutes presentation. My presentation is not going to be with numbers or formulas or algorithms, so just relax and listen. And then if you can agree with me, it's going to be great. So let me just give you a little bit of a background. AI is everywhere in the kids' life and our lives. It's hiding a lot of different places, but a lot of times kids don't know. And especially if you talk to elementary school kids, preschoolers, they think AI is magic. Is it really a magic? That's where the whole conversation we actually started amongst the educators. What should we do about it? And especially we want to really focus on the code biases, algorithm biases, AI ethics, because the way, sorry to say it, the kind of people involved into creating algorithms, less than half of the population, I'll guess, meaning mainly usually white, male dominated field. And my passion is how to make this field more diverse, to involve many different people, from women to people of color, minority people, because especially at the end of the day, not now though, but in the future, everyday people will be using AI in their everyday lives. And if they don't really fully understand what it is and how it's working, it's a bit scary in the sense that the people is going to be just a consumer of the technology than the user of the technology. So that's where this whole argument about, okay, we need to teach AI literacy to kids, and there are a group of people all over the world figuring this out, and there are like text here and there, but in the center, we meaning there is a group called AI for K-12 initiative in the US. It's an NSF-funded National Science Foundation funded project to come up with a guideline for educators to cover different components of basically big ideas of AI. So this is out there, and then we're figuring out what's the best way to teach it. And then also, this is in the US, but we have been having workshops and PAD for teachers to introduce different way of teaching with lesson plans and activities. So we have been doing it. And the new one coming up is going to be in December. I'm also part of it. CS is Computer Science Education Week. That's a big teacher-focused computer science education organization. And the one that I want to talk about today is, okay, take it back a little bit. We need to teach AI and AI literacy, we need tools. And my focus is computer science, robotics, AI education. And one of the things that I have been exploring is this little robot, which is the same size Android phone. And we usually use the Android phones that nobody uses anymore because it's like 3 generations old. And so we use those with a Arduino board, simple DC motors, to really figure out how kids can actually play with machine learning technology. And I don't know, it's 10 minutes, right? Or 15 minutes. There's a little video. Of course, I can't read it, but I'm just gonna say yes. Oops. Okay, so
I'm the UNESCO educational robot built with Google and powered by Infinix. Let me do some warm up here.
so this is how it looks.
Okay,
It's
I'm
really
ready.
simple.
Show me an object.
The reason why I started to, I don't know how to get back. I think I need to move this down. Okay. Yeah, that's fine. Oh, maybe here. Okay. Because it's really less expensive. Even you buy all together 3D print, it's $300 or even less than $100. So that's why this is practically good tool. But my question was, okay, how can we use this? So I started out with doing a little exploration kind of project with middle school and high school kids. And of course, middle school and high school kids get really excited. And I started to use it. For the machine learning part of it, we use something called Teachable Machine. I don't know how many of you know Teachable Machine. It's a Google tool, really simple, amazingly effective tool to actually for kids to train a machine learning model. But then if you don't apply it, that's that, just playing with it. So this tool allow kids to use the trained model with a robotic coding, which is simple scratch extension. So block coding was a little bit of a duh. I just say yes. Yeah. This is how it looks. Is it this? This one. So Scratch extension, this is all block coding. Scratch extension is that those extra blocks the developer actually created, and you can use that to use the training model in this block coding environment. So we have done that. Then because kids are kind of, it looks like kids understand it. So I'm like, okay, so we should probably start creating the lessons. So I brought my undergrad students in to use a teacher. Oh, this is about Teachable Machine. So it's a Google tool. You can go and then take a look at it. It's really, really fun. But then when we started to bring the undergrad students in, all computer science majors, and then some of them actually took machine learning courses, they understand it better than I do, I guess. But then it becomes really hard because when you train the model, if the computer is stationarized and camera is just looking at one direction, think about how you use that model on the robot that's moving around. The background changes constantly. And my students, my kids, had did struggle a lot to figure that out, which I was surprised because I thought they understand it. So instead of using the desktop, maybe have a phone, taking the picture, moving around, or but they just sort of stuck with this desktop idea. So they really, really
Okay.
hold on.
So
It just happens right
here
away.
we can see that
Having difficulty making the model that's sort of like perfect. So the first try around, this student was like, okay, so if the background doesn't have anything, so he started to use the cardboard and testing it out, it kind of worked.
So when I show it a yellow card, it should turn right or left. I forgot. Left. And then when I show it a red card, it will turn the other way. And when I show it a blue card, it should go backwards. And when I show it a green card, it should move forward. But it's kind of getting confused there. So
Yeah, so he's using the Uno card, different color. So it's like color coded, but he's saying blue and green are harder. It identifies a green, the blue, but the green is harder for the camera or the computer or this robot. And I think he didn't take the lighting into consideration. And actually, before this, I don't have the video of this, the other one. Before this, he was training a model when his computer was facing the window. Of course, the light is coming in. And then he was using the model on the robot in the box. And then, of course, none of them worked. Right? I mean, it makes sense to us or the people who actually have an experience, but he did it because for him, computer science major, everything is on the computer. So he had never done robotics before. So this was a sort of mind-blowing experience for him. So and then I had 2 computer science majors. There's still 1 more quarter left. So they're coming up back in fall, and then they're going to actually work more. But it actually it gave even the undergrad students who have trained to understand the machine learning and algorithm struggle, which was interesting. And if you can go to the presentation, I had a QR code at the beginning. There's a Python code he created so his next idea was to take a video using the phone and use the video using the Python code to convert the video into multiple pictures. So slice it out and then just take the picture files and then use that picture file, upload to the teachable machine, and then train a model. And he thinks that's actually better. And then I always have to remind them, well, at the end of the day, you have to create a lesson for high school kids. So you have to be able to explain that. And they're like, okay. So we'll see what's going to happen in fall. But this is just before the summer, this is what they were doing. So now Lobo is not moving because they're not so into now making a perfect machine learning model, which is okay for me. Because it's more like for me is the exploration of what kids will do. Kids meaning the undergrad students. So this is the video just before summer.
The result is pretty stable. And the result is empty.
So empty bottle. So if it's empty, the robot says empty. You can really read it. And it's going to be halfway full. I don't know why they wanted to do this. And then if it's halfway through, then the robot goes half. It shows half, but it's half is less stable than full. If it's full, robot usually identify it as full, but somehow halfway, half empty,
We can see
sometimes
the
confuses a
results
little
now.
bit. And their assumption is, I don't know why they're saying what they're saying. Their assumption is because there is a arm in the camera, but I'm not sure if that's
During the
true.
move,
But you can see that even undergrad students still struggling to figure that out, which is really interesting.
I think it's because
But
like,
so
its
one
positioning is
of the
different from
students
the
also
training.
said to me, well, my machine learning course instructor also said, even them professionals, they don't know what's going on because in the middle, the hidden layers, they don't know what's going on. So that's why it's okay to not know what's going on. That's his argument, which is kind of interesting. But that's also something that younger kids also need to know. This is not like even some part of the machine learning is computer deciding. So there are that's why sometimes it's difficult for even the professionals to figure out what to teach and how to teach.